Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about link state routing algorithm. So in this lesson, the learning outcomes are displayed. Today we are going to know about introduction to routing algorithms and also introduction to routing and also basic principles of link state routing algorithm and a small example which covers the link state routing algorithm and what are the advantages and disadvantages of link state routing algorithm. So first of all, let us discuss about what actually the meaning of a routing. It is a process of determining the best path for packets to travel from source to destination using various algorithms. So let us say that, so there are routers we have in the network which are responsible to carry the packets to the destination by selecting a path. And the router has to carry the information packet to the destination in a definite way. It has to reach to the destination without any problem. So here routing is a process of determining the best path for packets to travel from source to destination using various algorithms. Here what I am going to say is that, so there are routers here, let us say A, B, C, D are the routers as I am showing in the figure, and A can release the packets to reach the destination which can be B or C or D. So the router A can transmit the packets to every direction, whatever the direction it is possible in the network, so it can release all the packets to the other side. But in this case, there is a possibility of the packet may not reach to the destination in time, or they may be dropped by the problems that are there in the network. So a router is a device which is also called as a node, which is responsible to determine the best path for packets to travel. That means the guaranteed path and also the shortest path and also the definite path by which the packet can travel and finally it reaches the destination. So that is actually the meaning of a routing. So now, so to do this kind of process, there are various methods we have, and those methods can be called as routing algorithms, because from one router to another router there may be several paths, but out of all these set of paths there are certain paths which are optimal, so that the routing algorithm has to decide the optimal path. Based on that, the packet can reach the destination so in a most efficient way and by using the most efficient path. So that is actually identified in the routing algorithm. It is a method of finding out the most efficient path for the packet to travel from one router to the other router. So there are various algorithms we have, but of course we are going to discuss about one of them, that is called link state routing algorithm. So in the link state routing algorithm, so there are certain principles the routers definitely has to follow in this case. So in that, the first principle is nothing but knowledge about the neighborhood. So let us imagine that there are routers called ABCD, as I am showing in the previous network. So let us say that ABCD are the routers and there is a network like this. So here A is a router. In this link state routing algorithm, A has to identify the neighboring routers here. In the figure, the neighboring routers can be B, C, D are the neighboring routers in the figure. So the sharing of knowledge is possible between the neighboring routers in this particular link state routing algorithm. That is the first point. Suppose A, B, C, D are aligned like this. This is the way. Then A is going to share the information to B and to D. So it cannot share the information to C because C is not the neighbor to A. Similarly, B, if you take B, B can share its information to A and C. Similarly, C can share its information to B and D. Similarly, D can share its information to A and C. So this is the meaning of knowledge about the neighborhood. Then So this is the information sharing or knowledge sharing is possible by using the concept called as flooding. Already flooding is a very important concept by which every router is going to get the packets in the incoming line, and every router has to allow the packets to the all possible outgoing lines to that router. So this process is called as flooding. So in the link state routing algorithm, every router will follow the principles called knowledge about the neighborhood, and also it is going to follow a technique called as flooding, and also it is going to share the information. So knowledge about neighborhood is one important thing. So by that it is going to share its information to all its neighbors. So that is another important point we have to consider in this case of link state routing algorithm. So this is known as the actual basic principle that is observed in link state routing algorithm. And of course, in this link state routing algorithm, there are two phases that are to be carried out by every router. So here the first phase is called as the reliable flooding. Reliable flooding is possible. In this reliable flooding, in the initial state, each node knows the cost of its neighbors. I am going to show a small figure so that you can understand what actually the meaning of cost and what is the meaning of initial state and how the information can be carried out between the routers. That we can see by taking an example. But as a matter of this particular reliable flooding, so in the initial state, every node is going to know the cost of its neighbors, because the sharing of information is possible in this link state routing algorithm, so that in the initial state each node knows about its neighbor only basically, but in the final state every node knows about the entire graph. That means about all the nodes. So in the initial state only the neighboring node information is identified, but whereas in the final state every node is going to know about all its information about all the routes or nodes available in the entire network. So that is the meaning of entire graph. So these are the two states we can call as initial state and final state, which is possible by using a technique called as reliable flooding. And the next thing is called as route calculation. Once you know about the actual costs and information that is observed, information that is actually gained by the neighboring routers, then the next step is every router is going to calculate the actual what you can say the shortest route or the optimal route to all the nodes. It is going to calculate by following different algorithms, but of course we are talking about link state routing algorithm. So the algorithm, in this algorithm generally the Dijkstra algorithm, that means Dijkstra or Dijkstra, so this is the name that is generally been pronounced in number of ways, but of course the route calculation in the link state routing algorithm is basically carried out by Dijkstra algorithm. So based on that you can able to get the optimal route to all the nodes which are there in the network. So let us take a small example here. So in this example the graph is shown in which A, B, C, D are the routers. So carefully follow the example here. A, B, C, D are the routers, and let us say between A to B there is an edge that is shown here. On the edge there is a number that is indicated, that is called the cost. So that is the cost. So you need not worry about how the cost is actually shown here. So let us imagine that this is the graph which indicates the routers and also the cost that is actually measured, and that measured cost is shown on the edge. So like that. So from A to B there is an edge and the cost is 14, and from B to C there is one more edge, that is the cost is 1, and from C to D it is 4, and from D to A it is 5. And similarly from B to D there is one more link that is there, and which is showing a cost of 8. So in this particular graph, A, B, C, D are the routers or the nodes, but there are links which are actually connecting only some nodes. Okay, if you see in the figure, between A and C there is no direct link. So there may be some possibility, there may be some path to allow the packets to reach from A to C in some direction. But of course, we will see that how it is possible finally. But in this particular example, I am going to say that ABCD are the nodes or the routers, and the numbers which are on the edge are representing the actual cost factor. Suppose if you want to travel from A to B by using Dijkstra algorithm, in the link state routing algorithm, A is going to determine what is the least cost to travel from A to B, whether to go directly from A to B by using the cost 14 or any other way is there. So that is a basic process, or that is a basic calculation that will be made in this case of link state routing algorithm by using Dijkstra algorithm. We'll see in detail about how these things can be carried out. Okay, how this in the link state routing algorithm, the router will maintain the data, because already I told you that every router is going to share its information to its neighbor. So what information it is going to share and what do you call that information? So that can be here referred as a link state package. Every router before actually deciding about the distance, the shortest distance, it is going to say a hello packet, or which is also called as a link state packet you can call, which says about some factors called the name of the node and also the sequence number, and TTL is one more field that is there, that means time to live, and based on the actual figure or graph. So the neighboring node that is existing to the actual current node, whatever we are discussing, so that is represented in line. So this is the way how the link state packet is going to share the information. The link state packet is nothing but an informative packet. You can also call it as a hello packet. So thereby it is going to share its information to its neighbors. So by stating that from where the information is coming and what is the cost factor, so and how much time it is going to live in the network, and what is the number of the packet that is releasing by the router. So these are the information. This is the information that is actually shared by the neighboring routers in this case. So in this case of this example, if you see that there is a link state packet by taking into consideration the router A. So the name of the router is shown on the top, and sequence numbers, that means A can release number of packets to all directions. So suppose A is having 10 packets, how the neighbors can understand what is the first packet and what is the 10th packet. So to make it clear, so the router is going to indicate the sequence number so that the neighboring routers can able to understand, so what is the number of the present packet or current packet, and is it duplicated or is it the new one. So they can able to identify by knowing the exact sequence number of the packet in the transaction. That is the reason sequence number is shown in this. And next, time to live. So in this case of the network, every packet will be estimated with some kind of the time to travel in the network to reach the destination. That means generally it will be in terms of hops you can able to refer in this case. Okay, suppose A is going to reach to C, so it may take 2 hops. Either it may go to A to B or B to C, or it may go like that A to D or D to C. It can be called as a 2 hops. It is starting from A, it is reaching to C. Between these there are 2 hops, let us consider in that way. So TTL is referred as 2 here. Once it is taking the first hop, it will be decremented by 1. It is taking the next hop, it is decremented by one more. So that finally by reaching to 0 TTL value, so it has to reach to the destination. Otherwise the packet will be dropped. So that is the purpose of TTL that is shown in this case. And of course, B and D are the neighboring routers of A. So A neighboring router is B here, and one more neighboring router is D. So that is the reason. So B to A, the information, the cost is 14, it is identified, and A to D, the cost is 5. So this is the way how the link state packet reveals the information of the neighbors. So from this link state packet, what you can understand? So the name of the router and what is the number of the packet and how many hops it is expected to travel and what are the neighboring routers and what is the cost factor of the neighboring routers from the current node. So this is the information that will be maintained by all the routers as I am showing that in the next slide. So this is the link state packet maintained by B, just following the same phenomena. Okay, for B there are three neighboring routers A, C and D. So in the table also you are able to find out A, D, C. Of course the number 14, 8, 1 are the respective costs which are shown in the figure. And of course on the top you are finding B, there is the name of the router, sequence number, TTL are of course they are carried out in all the link state packets as I mentioned in the earlier one. And for C also you can able to see the packet, link state packet. Similarly for D also you can able to see the link state packet. So this is the information that is actually identified or received at every router from its neighboring routers. So this is the first point what actually I told you in the actual basic principle of link state routing algorithm. So this is the information that is identified at every router. Now if you see all the link state packets at all routers, so this is the scenario. So A LSP, B LSP, C LSP, every router is having its own information about its neighbor. So this is called the overall link state packets of all the routers. Now based on this what you can understand. The next thing is how to calculate the shortest route. Even though A to B the distance is 14, it is displayed, but that may not be the shortest or but may not be the cheapest one. So there may be some other route which may lead in a shorter way, so that in the link state routing algorithm there is a process called a dist algorithm. So in that algorithm it is going to calculate. So other than this path, any other path is there which is going to display the shortest or the cheapest or the efficient path or optimal path is there in the complete network or not, can be identified in this link state routing algorithm by using dist algorithm. So for that this information is necessary. Based on that it is going to calculate. How it is going to calculate is shown in this graph. So the left part, the left side part, there is a block. This is what actually I have shown in the previous slide. This is the information of all the routers with its link state routing packets. But if you see the right hand side portion, this is the big graph you are finding here. So this is the block in which the updates are taken place, because A is having the information about B and D, but B is also having some information about ADC. Similarly, C is having some information about DB. So similarly, D is also having some information about A, B and C. So based on all these things, so finally A is going to recalculate what is the cost from A to all the other routers here. So that is why it is going to update itself by taking the information of the neighbors, and finally it is going to update itself for the whole network. So that is the beauty of this particular routing algorithm. Now if you see this, you focus on the router A here. So in this there are three columns that are mentioned in every routing table. This is called the routing table information. The routing table information is consisting of three columns. The first column is saying about the destination of every router and the distance from that router to the destination, and also next hop. That means in which direction the packet has to travel. What is the next hop? That means which router is the next router which can give advantage, or which can take the packet and carry to the other side. So that is the meaning of next hop here. Let us imagine by taking the example of A router here in this. So here A router is having the 4 rows A, B, C, D. The first, let us start with A. So A is the starting node, and of course from A to A the distance is 0, and there is no next hop for that because we are traveling from A to A. So next hope is only A itself. So that is the information in the first row. If you come to the B, so let us say that the A to B distance we have to calculate. So here the distance algorithm is going to play a very important role. Already in the graph we are directly finding a route from A to B, which is saying that 14 is the cost. But in the distance algorithm, by using distance algorithm, so there will be some calculation. Any other path is there which is going to reduce the cost factor. So if you see this, by getting the information of the link state packets of B, C, D respectively, A can recalculate, because there is one more direction of reaching to A to B. So A can go to D, from D to C, from C to B it can go, or otherwise from A to D, from D to B it can go, like that. So to make it clear about the paths, available paths from A to B, basically there are three paths. Directly from A to B is one path, A to D, D to C and C to B is another path, or A to D and D to B is another path. There are three paths we are able to identify. So now again it is going to calculate what is the shortest path. Suppose if you go directly from A to B, it is taking 14 units, let us say. Now the other path is A to D and from D to B, let us say. So then what is the cost of that? This 5 plus 8, so it is making to 13. Okay, so let us keep it like that. And what is the other path? A to D, D to C and C to B. So A to D is 5 and D to C is 4 and C to B is 1. That means 5 plus 4 plus 1, it comes to 10. So now you compare, 14 is one cost, 13 is another cost and 10 is the third one. So now it is going to compare which is the least cost in this. So naturally 10 is the least cost value, so that so from A to B the path can be of distance 10 units, and the hopes are also mentioned here, which direction the packet has to travel. Suppose if it is starting from A, first of all it has to reach D, that is the next hope value, D here. After that it should not go to the direction of B directly, so it has to take the help of C router here. So that is the meaning of next hope C here. So that is why once it is traveling from A, it has to first of all touch D, and after that it has to touch C, then finally it can reach the destination that is called B. So based on that, even though A to B direct value is 14, but in the calculation, so it is recalculated and finally from A to B the distance is 10. This is the least cost value as far as the present graph is concerned. Okay. So like that, so all the values, costs from A to C and A to D will be calculated. Suppose if you see A to C, let us say, A to C, there is no direct path. But because there is sharing of information by the neighboring routers, because C information can be shared to D and C information can be shared to B. So D can share the information to A and B also can share the information to A. Finally, A will get the information of C also. So that is the reason the A can also calculate the distance from A to C. So based on that, it is going to say that from A to C the distance, first of all you see what are the available paths. From A to C there is no direct path. So you can go like this, A to B and B to C, that is one path, or A to D or D to C, there is another one. Okay, suppose if you see that A to B and B to C, so it comes to 15, the value is 15 because A to B is 14 and B to C is 10, B to C is 1, so it is 15, it comes to 15. Suppose if you travel from A to D and D to C, it is 5 and this is 4, so 5 plus 4, this is nothing but 9. Okay, so that is the reason in this routing table of A to C distance is shown as 9, and which is the next hope, that means in which way you are going to travel is also indicated by the next hope letter here, that is D. You should not travel from A to B, you have to travel with the help of D router only, that is the meaning of next hope here. Like that, A to D is having direct path of indication of 5 but it may not be true in some other cases. Suppose the values are less in some other direction, so you can go like that. But fortunately, in the graph it is shown that the distance from A to D, or the cost from A to D, is 5. Possibly this is the least cost value, so it can be maintained as it is. Like this is the way how the Dijkstra algorithm is going to calculate the shortest paths, or the least cost paths from one router to all the other routers in the computer network. So you can imagine the other routing tables of B, C, D respectively. You can identify why the costs are shown like that. 10015 or 9104. Why these costs are shown here? So you can able to identify just what I mentioned, the process of the router A. Similarly, the process will be carried out at every router B, C, D respectively, and you can get the tables like that. So these are the updated routing tables of the routers. So like this, in the link state routing algorithm, the neighboring routers will share its information to the routers, all other routers, and also the flooding is another important thing, and information sharing another important principle. Based on that, the final calculation of the least cost will be identified by using the algorithm called as Dijkstra algorithm. So what are the advantages in this? So here the main advantage is it is scalable. That means because the network, if it is very complex, then it is very difficult to manage. But whereas in this case of the link state routing algorithm, you can able to measure it, what are the actual cost factors, and how you can able to modify them, and how you can able to calculate. Everything is in control. So that is why it is called as a scalable kind of feature is available in this case of the link state routing algorithm. And fast convergence, that means so even though there are a number of paths from the source router to the destination router, but by using this algorithm, you can very fastly you can able to identify the optimal path among all the possible paths from the source router to the destination router. So you can able to identify the optimal path very easily. So that is called fast convergence. And accurate routing. So I already told you optimal in the sense that is the best. So that is why the accurate routing is nothing but because you are able to identify the optimal path. So definitely that path leads to the transaction in an accurate manner. That is the meaning of the routing. Accurate routing is possible in this case of link state routing algorithm. And also the next one is called event driven updates. So here in this case of the link state routing algorithm, whenever any change is taken place in the network, suppose suddenly B is dropped, the router B is dropped, then the information should be shared, and based on the information sharing, the router A information has to be updated. So whenever B is dropping, then only it is going to update its table. So that is why event driven updates. So here manually you cannot update. Whenever something is changed in this, something is modified, then only the updates will take place in this case. So that is why event driven updates are possible in this case of link state routing algorithm. Also there are several advantages in this case of link state routing algorithm. Higher complexity. Suppose if the network is simple, you can able to manage, but it goes on extending, so it is very difficult to manage. So complexity automatically raises here. So that is why it is one of the disadvantages of the link state routing algorithm. And next one is called as memory requirement, because the routing table is going to store some information about the neighbors and their status, and everything is it has to maintain in the form of a table. So whenever it is going to maintain data, definitely it needs some memory. So finally I am going to say that if the network is complex, then automatically it needs more and more memory to manage the information about all the neighboring routers, and also the overall graph information. So it needs more and more memory. And processing requirements. Suppose the network is complex, of course it is going to use a Dijkstra algorithm or any other algorithm, but of course In the process, it has to actually use its logic, so that it has to cover every possible path, and finally it has to find out the optimal path. If the network is extending in a complex manner, then the actual processing logic is also will be more complex, and also finally it takes time, and also finally it is going to give you some kind of an output at a later stage. Bandwidth requirement. Suppose if the network is going on extending, so definitely because of the packets and the release, sometimes the bandwidth may not be sufficient because the network capacity is having some limitation. So if you go on extending the actual network and you go on extending the packets to travel in the network, automatically some moment the bandwidth may not be sufficient to hold the packet, so that the bandwidth will be a major factor here to as a requirement. You have to pursue on that, and you have to manage the bandwidth as and when it really requires. So these are the basic disadvantages of the link state routing algorithm. Hope in this lesson you are able to see what actually the routing means, and what do you mean by routing algorithm, and what are the basic principles of link state routing algorithm. Let us discuss an example called link state routing algorithm, and what are the advantages and disadvantages in this link state routing algorithm. Thank you.